Hello everyone. So welcome you all in today's session. So today we will continue sequences and series and we will cover all the questions of exercise 8.2. So be ready with your pen and notebook. So yes, we are starting our question number 1, right? So here we have to find 20th term and nth term of given GP, right? So first of all, I'm writing the standard form of GP. So it is AR, AR square, and so on. Here A is called first term, right? So first term is what? If we talk about this GP, so here A will be what? 5 upon 2, right? And if we talk about what? R. So how to calculate R? R is always calculated by dividing. Suppose this is A1, this is A2, A3, A4. So AR is what? A2 upon A1 or A3 upon A2, right? So here R will be what? R will be equal to 5 upon 4 divided by 5 upon 2. Or we can write it as 5 upon 4 into 2 upon 5, and R will be equal to what? 1 by 2, right? So now we have A and R. So easily we can find the nth term. So what will be nth term? Yes, nth term is already always given by A into R raised to power n minus 1. So R is already given. R is what? 1 upon 2 and A is 5 upon 2. So this will be 5 upon 2 into 1 upon 2 raised to power n minus 1, right? So guys, I think everybody is aware about the formula we use in exponents. So x upon y raised to power m. So this can be written as x raised to power m and upon y raised to power m. So here what we can do, 5 upon 2 is as it is and 1 raised to power n minus 1 will be as it is and 2 raised to power n minus 1 is this one, 2 raised to power n minus 1, right? So we have another formula x raised to power m into x raised to power n. So that will be what? X raised to power m plus n. So what we can do? We can write it as, yes, 5 upon 2 into 2 raised to power 1 is there. So this will be what? 1 plus n minus 1. And 1 and minus 1 are cancelled out. So it will be 5 upon 2 raised to power n. Right? So an is what? An will be 5 upon 2 raised to power n. So now what we want to find? 820. So nth term is given. So I think 820 is very easy to find. Just replace n with 20. So 5 upon 2 raised to power 20. So that will be the 20th term, right? So in this way, we can find 20th term and nth term of a GP. So let us move to another question. So here we have to find 12th term of a GP whose 8th term is already given, right? So let us write what is given. So A8 is equal to 192, right? And we had already discussed how to write nth term. Yes, an is equal to a into r raised to power n minus 1. So if you want to write a8, so a8 will be what? Yes, a8 will be a into r raised to power 8 minus 1, right? And it is equal to 192. And look at this one, r is already given. R is equal to 2. So what we can do, here we can write r as 2 and 8.8 minus 1 is 7, 192. So 192 will be what? If you factorize 192, so it will be, yes, 2 raised to power 6 into 3. So if we divide both sides by 2 raised to power 7, we will get the value of A. So value of A will be 3 upon 2, right? So we have the value of R, we have the value of first term A. So now easily we can find the 12th term. So 12th term will be written as, yes, A12. A12 will be what? A into, yes, A is what? Or I'm writing first of all A into R raised to power 12 minus 1. So what is A? A is 3 by 2. And what is R? 2 raised to power 11. So this will be 3 into 2 raised to power 10, right? And 2 raised to power 10 is what? 1024. And this will be what? 3072. So A12 will be 3072. So in this way, easily you can find the 12th term. So guys, if you want to find any term of a GP, so you need what? A, first term, and common ratio, right? So let us move to next question. So here, 5th, 8th, and 11th terms of a GP are P, Q, and S, right? So we have to prove Q square is equal to P into S, right? So what we will do, first of all, we will write our nth term. So nth term of a GP is A into R raised to power n minus 1. And what is given? A5 is given. A5. A5 will be what? A into R raised to power 5 minus 1. So I'm directly writing 5 minus 1 means 4. And this is equal to what? This is equal to P. Similarly, A8. A8 will be A into R raised to power 8 minus 1. So that is 7. And that is equal to Q. And A11. A11 is A into R raised to power 11 minus 1. So that will be 10. And this is equal to S. Right? So we have to prove Q square is equal to PS. So let us write LHS. LHS is what? Q square. And Q square is what? Q square means, yes, Q square means it is A8, 8th term square. So this can be written as, yes, this can be written as, we have A into, yes, R raised to power 7 square, and this will be Q square. So what is the value of Q square? Q square will be, yes, A square R raised to power, yes, 7 to the 14. So here again we are using that exponent formula, x raised to power m into n. So that will be x raised to power mn, right? So this is Q square, right? So now let us find P into S. Right hand side is P into S. So what is the value of P? It is, yes, A into R raised to power 4. And what is the value of S? It is A into R raised to power 10. Right? So A into A, it will be A square. And R raised to power 4 and R raised to power 10. So we will add the power. So 4 plus 10, 14. So look at this one. Q square is A square R raised to power 14. And PS is also A square R raised to power 14. So it means Q square is equal to PS, right? So in this way, we can easily prove required condition. So let us move to another question. The fourth term of a GP is square of its second term. So guys, always remember, whenever we have any like word problem is given, so what we do, we change English to mathematical language. So if we talk about first line, the fourth term of a GP means fourth term means A4 is square of its second term. Second term of a GP will be A2. So this is given. A4 is equal to square of A2. And the first term is minus 3. So first term, this is given. So we have to find its seventh term, right? So seventh term we have to find. So to find seventh term, what we need? A into r raised to power 7 minus 1 means we need value of r. A is already given. So let us solve this one. A4. A4 will be what? AN is already, I'm again writing AN, right? So once you will solve these questions, so like easily you will learn all these formulae. AN is what? A into R raised to power n minus 1. So A4 will be what? A into R raised to power 4 minus 1. So directly I'm writing it 3. So A2 will be what? A, yes, R, right? 2 minus 1. So directly I'm writing AR. So this will be A square, right? So here it will be what? AR cube is equal to A square R square, right? So if you simplify this one, so what you will get? R will be equal to A, right? So A is already given. So it means, yes, R is also equal to minus 2, right? So now easily you can find A7. So what will be A7? Yes, A is minus 3 and R is again minus 3, right? So we had discussed in previous lecture, always remember if negative raised to power even is given, so result is always positive, right? So here inside this minus 3 raised to power 6, so result will be positive, but outside we have minus. So it will be what? Minus 3 into, yes, 3 raised to power 1. So this will be what? 3 raised to power 7. So what will be the final answer? Yes, it will be minus 2187, right? So A7 will be minus 2187, right? So let us move to another question now. Yes. So in question number 5th, so we have parts of 5th. So let us discuss first part. Which term of the sequence this is 128, right? So first of all, you will check if only sequence is given. So you have to check whether it is APGP, right? So if we talk about this one, so here A is 2, right? And look at this one. This is A1, this is A2, this is A3, right? So we will check whether A2 upon A1 is equal to A3 upon A2, right? So that will be for GP. And for AP, it will be A2 minus A1 will be equal to A3 minus A2. So let us check A2 upon A1. So here 2 root 2 divided by 2, A3. A3 is 4. So 4 upon 2 root 2. So yes, if we simplify this one, so it will be root 2. And if we simplify this one, so 4 can be written as 2 into 2. 2 is cancelled out and 2 can be further factorized as root 2 into root 2. So here both are same. It means this is a GP. So first term is 2 and common ratio is what? Root 2, right? And it is given, we have to find which term of the sequence is 128, right? So it means it is given this 128 is nothing but it is an. So an is what? An is a into r raised to power n minus 1, right? So if it is 128, so then a is what? A is 2 and r is root 2 and n is unknown, right? So 128. So if you factorize 128, so what will be the value of 128? Yes, it will be 2 raised to power. Yes, 2 raised to power 7. Yes. And this is equal to, or you can divide it by 2, right? And this will be what? Root 2 raised to power n minus 1. And this will be what? 2 raised to power 6. So that is equal to root 2 raised to power n minus 1. Right? And we had already discussed 2 can be written as a root 2 into root 2 or a root 2 square. So what we can do, left hand side, this one, I'm writing here. So this can be written as root 2 raised to power 2 into 6. So this will be 12. And right hand side we have root 2 n minus 1. So here we have a rule in exponents. If x raised to power m is equal to x raised to power n, then m will be equal to n when x is not equal to 0 or plus minus 1, right? So what we can do, we can compare the powers. So 12 will be equal to n minus 1. So n will be equal to 13, right? So here, which term of the sequence is 128? So we had assumed this is en term. N is 13. So it means 30th term of this sequence will be 128, right? So let us move to next part. Again, same or like this is the previous type. Which term of the sequence is this one, right? So what we will do, first of all, we will find A. So A is given. R will be what? R will be 3 upon root 3, right? So we will check whether it is equal or not, right? We are solving questions related to GP, so it is already understood. This will be R, means A2 upon A1 will be equal to A3 upon A2. But in actual paper, when you will find different questions from different topics, so always remember, then first of all, you have to check whether the ratio of these sides, right? Ratio of terms, A2 upon A1 is equal to A3 upon A2. So if we check this one, so it is what? 3 can be written as root 3 into root 3. So it is root 3, right? And this can be again 3, 3 gone. So root 3. So it means R is a root 3, right? So A is given, R we have calculated. So which term of this one is 729? Let us assume AN term is 729, right? And AN means what? A into R raised to power n minus 1, right? So guys, your formulae must be clear. These questions are purely based on formulae. I'm telling you the process, what are the steps we require to solve these types of questions. But if formulae are not clear, so you cannot proceed further. So here an is what? A into r raised to power n minus 1. So this will be 729. And what is the value of a? It is root 3. And r is root 3 raised to power n minus 1. right? And this will be 729. And 729 can be written as what? It can be written as 3 raised to power 6, right? So further, we can write it as root 3. So this can be written as, this is raised to power 1, and when we will write it as x raised to power m into x raised to power n, so this will be, power will be added, so 1 plus n minus 1, so this will be simply n. And 3 can be written as root 3 square and whole 6, so this will be, yes, root 3 raised to power 12. And if you compare the powers, so n will be equal to 12, right? So which term is 729? It will be A12. Means 12th term of this sequence will be 729, right? So let us move to next, third part of this question. Which term of the sequences? I think now everybody is clear how to solve these types of questions, right? So first of all, you can stop the video at this point. You can try yourself. So then you can check whether your answer is right or wrong, right? So here A is 1 by 3. So I will check the value for R. So it is 1 upon 9 in 9 upon 1 upon 3. So directly I'm writing it as 3 upon 1. So that will be equal to what? 127 into 9 upon 1. When we change any division to multiplication, so we take the reciprocal. So here we will get what? 1 upon 3, and this is also 1 upon 3. So it means R is also 1 by 3. So A and R are same, right? So here which term of the sequence is this one? So same process. Nth term of this sequence is 19683, right? So nth term is given by A into R raised to power n minus 1, and this will be as it is. So guys, here you have to do the prime factorization of 19,683. So A is given 1 by 3 into 1 by 3 raised to power n minus 1, and directly I'm writing this 19,683, right? So this will be what? 3 raised to power 9. This. So 1 can be written as 1 raised to power 9. So this whole will be written as 1 upon 3 raised to power 9, right? So now this will be what? This is raised to power 1. So here we will have 1 upon 3 raised to power 1 plus n minus 1. So this will be n only, and this will be 9. And if we compare these terms, so n will be what? N will be 9, right? So which term of this sequence is 120? This 1 upon 19,683, it is ninth term, right? So I hope everybody is clear about these three questions are there, but type was same. So let us move to another question. So here we have to find what? For what values of x, the numbers days are in GP, right? So we had already discussed the standard form of GP is AR square, and so on, right? So whenever we check whether a sequence is in GP or like AP, so what we do in case of AP, so we check the common difference, but here we will check the common ratio. So let us assume this is the first term, This is the second term and this is third term. So A2 upon A1 will be equal to A3 upon A2, right? So what is A2? A2 will be what? X upon minus 2 upon 7. And this will be minus 7 upon 2 divided by x, right? So if you do the cross multiplication, so x square will be equal to what? Minus 7 upon 2 into minus 2 by 7. And this will be equal to 1. If x square is equal to 1, so x will be equal to plus minus 1, right? So for what values of x? So these are two values. X is equal to 1 comma minus 1. For these values of x, so these given numbers, so they will form a GP, right? Okay, so let us move to question number 7. Now in question number 7, this is the next type, right? Why? Because here they are asking for sum. In previous, all the questions till 6, we were finding what? A specific term, nth term or a 20th term, right? Or whether it is in GP. But here we have to find what? Sum. To find the sum to indicated number of terms in the given GP, right? So terms are given and n is what? 20, right? So I'm writing the formula. First of all, I'm writing the standard GP. First term is A, common ratio is R, and nth term is A into R is to power n minus 1, right? Whenever you find the sum, always remember what we do on the basis of R, we apply the formula to find sum of n terms, right? So I'm writing both the formula for sum of n terms. So it is what? It is A into 1 minus R raised to power n divided by 1 minus R when R is less than 1, right? And sum of n terms will be what? A into R raised to power n minus 1 divided by R minus n when R will be greater than 1, right? So now let us solve this question. So here A is what? A is 0.15. If we want to find R, so R will be what? 0.015 divided by 0.15, right? So this will be what? If you solve this one, so you will get 1 upon 10 or 0.1, right? So R is calculated, A is calculated. So easily we will find the sum of 20 terms. So N is 20, so S20. Yes, guys. We will apply which formula? Yes, very good. We will apply first formula because here R is less than 1 and here we are having R is equal to 1 upon 10. So S20 will be what? A is 0.15 into 1 minus R. R is 1 upon 10 and it is raised to power 20 and whole divided by 1 minus R. R is 1 by 10. Right, so let us write it in simplest form 0.15. It can be written as 15 upon 100 and I'm changing this division by multiplication. So it will be what? 10 minus 1. So 10 minus 1, it means this will be 9 upon 10. So if we multiply this with, so this will be its reciprocal. So 9 upon 10. So we will write 10 upon 9 and rest will be same. It will be 1 minus 1 upon 10. So let us write it as 0.1 raised to power 20. So if you solve this one, so you will get what? 3 2, this will be 3. So S20 will be what? S20 will be, yes, 1 upon 6. 2 3s are 6, yes. Into 1 minus 0.1 raised to power 20. Right? Yes. So this is the answer. This is the final solution. You guys cannot use the calculator, so we will not simplify this further. So we will write it as 1 upon 6 into 1 minus 0.1 raised to power 20. So this will be the sum of 20th terms of this GP. So let us move to another question. Find the sum to indicated number of terms in the given geometric progression. This is just as previous question, but here n terms are given, right? So what we will do, we will find Sn, right? So first of all, A is what? A is root 7, right? Root 7. Root 4 is 2. So root 7 will be more than 2, right? And what about R? Yes, R is root 21 divided by root 7. And here it will be root 3 into what we can do, root 21 can be written as root 3 into a root 7, and root 7 we have, so it will be root 3. And root 3 is what? 1.7, right? So here R is root 3, and which is greater than 1. So now, yes, we have written both the formulae. So here Sn will be what? A into, very good, R raised to power n minus 1, R minus 1. Why? Because R is greater than 1. So what will be Sn? A is root 7 and R is root 3. Whole divided by, yes, root 3 minus 1. So next step, what we will do, because in denominator we have root 3 minus root 1, so we will do its rationalization. So if we, for rationalization, so we will take its conjugate. So root 3 minus 1, so we will multiply and divide this Sn. Why what? Root 3 plus 1 and root 3 plus 1. So now you can see in the denominator, we are having what? Root 3 minus 1. So a minus b into a plus b. So this will be a square minus b square. So this will be directly 3 minus 1. So I'm writing the Sn as what? Root 7 upon 2, right? And this will be what? Root 3 plus 1. And here it will be root 3 raised to power n minus 1. Right? So finally we have root 7 upon 2, root 3 plus 1. Yes, root 3 raised to power n. Or you can write it as 3 raised to power n upon 2. Right? So in this way, you can find the sum of nth terms. So let us move to another question. Find the sum to indicated number of terms in the given geometric, just like previous question. I think you guys can try this question now. So let us solve together now. A is 1. R is what? Minus a upon 1. So it will be minus a, right? So what will be Sn? Yes. Now this time, many students, so they will get confused. So whether we will apply first formula when R is less than 1 or R is greater than 1, right? So here you can apply any formula because it is given A is not equal to minus 1, but you can use other than -1. You can use whether it is negative, positive, right? So we can apply any formula. So Sn will be what? A into r raised to power n minus 1 divided by r minus 1. So what is A? A is 1, r is minus a raised to power n minus 1 divided by minus a minus 1, right? So what is the simplified form of this one? R is minus a, yes. So this will be what? This will be finally we are having, you can take minus as common, or you can leave this as it is, or what you can do, you can take minus as common, so this will be the final one, right? Otherwise, if you apply the formula, this a into, those who are applying this formula, so we will get what? A is 1 minus raised to power n divided by 1 minus, right? So what we will get? We will get 1 minus a raised to power n 1 plus a, right? So in this way, you can solve this question and you can find the sum of n terms. Those who are using this formula, so they will get this result, and those who are applying this formula, so both are same, right? Both results are same. You will get the full marks. So don't worry. So let us move to next question. So find the sum to indicated number of terms in the given geometric progression, just like previous question. Again, terms are given, right? So A is what? A will be x cube. R will be what? X raised to power 5 divided by x raised to power 3. So this will be x raised to power 2, right? So what will be Sn? Yes, Sn is equal to A into, yes, 1 minus r raised to power n upon 1 minus r. So I'm using this formula. So A is what? X cube, and 1 minus r is what? X square raised to power n divided by 1 minus x square, right? So I think there is no need to simplify this one, because we can only write it as x cube into 1 minus x raised to power 2n divided by 1 minus x square, right? So in this way, you can solve question number 10. So we have seen like different types till 10, but guys, you have to remember the form, right? Standard form, if you know the standard form, then you can easily, what you can do, you can easily find A and R, right? A is first term, R is the common ratio. So then nth term is what? A into r raised to power n minus 1. And sum of n terms we had already discussed. So we will apply this formula when r is less than 1. And if r is greater than 1, so this will be r raised to power n minus 1 divided by r minus 1. This is very simple, right? So now question number 11. So here we have to evaluate sigma k equal to 1 to 11, 2 plus 3 raised to power k. So always remember, whenever there is a sigma, so it means they are talking about series, right? Means we have to find the sum. So what we can do, we can write it as sigma k equal to 1 to 11, 2 plus sigma k equal to 1 to 11, 3 raised to power k, right? Because we have a rule, if sigma of f plus g is given. So what we can do, we can write it as sigma f plus sigma g. So now this one, so we will write it as 2 plus 2 plus 2 and so on up to how many times? It is 11 times. 11 times. And this one, yes, so this one will be written as plus 3 raised to power 1 plus 3 raised to power 2, 3 raised to power 3 and so on up to 3 raised to power 11, right? If we see this one 2 plus 2, how many times? 11 times. So this means 2 into 11, it will be directly 22. And here if we see this one, so this is the GP, right? So here A is 3 and R is 3 square upon 3, that is again 3. So we have first term and common ratio, so easily we can find the sum of these 11 terms. So now this will be what? We will use, yes, I'm again writing the formula. So here R is greater than 1. So we will use A into R raised to power n minus 1 divided by R minus 1. Right? So A is what? A is 3 and 3 raised to power 11 minus 1 divided by, yes, 3 minus 1. Right? So finally, the sum of this one is what? It will be 22 plus, yes, 3 upon 2 into 3 raised to power 11 minus 1. So this will be the final answer, right? I hope everybody is clear about this one. So now moving to next question. So here it is given the sum of first three terms of a GP is 39 upon 10 and product is 1. Find the common ratio and the terms, right? So always remember, so we had discussed in AP, whenever they are only talking about three terms, right? So what we were assuming the terms, so it was A minus D, A and A plus D. So similarly, whenever you will find GP and these types of questions are there, so they are talking about only first three terms. So we will assume first three terms as A upon R, A and AR, right? We will not assume AR square. I will tell you why this will be very easy. So now, according to given question, sum of first three terms is what? 39 upon 10. So A upon R plus A plus AR. So that is equal to 39 over 10. So this is the first equation. And second is what? Product. So product is A upon R into A into AR. So that is equal to 1. So if we simplify this one, so R cancel out. So A cube is equal to 1, right? So this means A will be equal to 1. So in this way, we will get first term. Now what we will do, we will substitute A equal to 1 in first equation. So what we will get? We will get 1 upon R plus 1 plus R. So that is equal to 39 upon 10, right? So then what we will do, we will take the LCM of left hand side. So this will be 1 plus R square divided by R. This is equal to 39 over 10, right? So now we will do the cross multiplication And finally, we will get what? It is 10r square, right? So 10r square plus 39, and this will be plus 10r. So here I'm writing the final quadratic equation. So that will be in r and plus 10, right? So this is the final quadratic equation. So I think everybody is aware about how to factorize this one. So this will be, we will break 29r in such a way that sum will be minus 29 and product is 10 tens are 100. So minus 25 and minus r. So I'm directly writing the final factors due to space constraints. So this is 5r minus 2 and 2r minus 5. So finally you will get r is equal to 2 upon 5 or 5 upon 2, right? And if r is 2 upon 5, so then yes, a is 1, so 1 upon 2 upon 5, so that will be 5 upon 2, 1, and 1 into 2 upon 5. So this will be 2 upon 5, right? So these are the first three terms, right? So when you are taking 2 upon 5. So if you take, so this was for this one. So now if 5 upon 2 is there, so this will become what? 2 upon 5, 1 and 5 upon 2. In both the cases, terms will be same, right? Order is different, but terms are same. So first three terms will be 5 by 2, comma 1, comma 2 upon 5, or 2 upon 5, comma 1, comma 5 upon 2, right? So in this way, you can solve question number 12. Let us move to question number 13. So now how many terms of GP? GP is already given, are needed to give the sum 120, right? So AP is already given, GP is already given. So A is 3, R is 3 square upon 3. So that is again 3. And it is given sum, right? How many terms? So terms are unknown. So it means they have given sum of n terms is equal to 120, right? So R is greater than 1. So here we will use the formula to find sum as, yes guys, Sn will be A into R raised to power n minus 1 divided by R minus 1. So Sn is what? Sn is 120. So then A 3 into 3 raised to power n minus 1 divided by 3 minus 1, right? So this will be what? If we simplify this one, so 40, and this will be 2, 3 minus 1. So directly I'm writing it as 80 is equal to 3 raised to power n minus 1. So in next step, 3 raised to power n will be 81, right? And 81 can be written as what? 3 raised to power 4. So n is equal to 4. It means how many terms? 4 terms are required, right? To make the sum 120. So now question number 14. The sum of first three terms of a GP is 16 and sum of next three terms is 128. So we have to find first term A, common ratio R, and sum to n terms. So Sn we have to find, right? So now what we can do, we will write the standard GP, right? I think everybody is aware about this one now. So here, according to question, sum of first three terms. So A, AR, AR square. So this is equal to 16. And next three terms. So AR cube plus AR raised to power 4 plus AR raised to power 5. And this is equal to what? 128. Right? So what we can do, we can take A common from this one. So we are left with 1 plus R square. and this is equal to 16. So I'm writing this as first equation, and from here AR cube is common. So 1 plus R square. So this is equal to 128, right? So now guys, what we can do? We can divide 2 and 1. So 2 upon 1. So that will give us what? A will be cancelled out. So R cube is left. So R cube is equal to, yes, 128 divided by 16, right? And this is what? 8, 16 8 is a 128, and 8 can be written as 2 raised to power 3. So R is what? R is 2, right? So now common ratio is R equal to 2. Now to find first term, what we will do? We will substitute R equal to 2 in first term. So if we will substitute R equal to 2 in first term, so we will left with A into 1 plus R is 2. So 2 plus 2 2s are 4 is equal to 16. So A will be what? 16 over 7. Right? So A is equal to 16 upon 7. So first term is 16 upon 7 and R is 2. So easily we can find sum of n terms, right? And this time, guys, again, R is 2. So greater than 1. So we will use the formula Sn is equal to A into A is what? 16 upon 7. So R raised to power n. So 2 raised to power n minus 1 divided by 2 minus 1, right? And if you solve this one, so only like 16 upon 7 will be there, and 2 minus 1 is 1 only, and this will be 2 raised to power n minus 1, right? So I think everybody is clear about this one. So sum of n terms, yes, 16 upon 7 into 2 raised to power n minus 1. Very good. So in this way, we can solve question number 14. So let us move to question number 15. So here it is given given a GP with A equal to, so first term is already given, seventh term is 64. So find S7, right? So seventh term. So yes, guys, how to find A7? A7. So now you're solving 15 questions. So I'm not writing the formula. Directly we are writing A7. A7 will be what? A into R raised to power 7 minus 1, and that is equal to 64, right? So here A is what? A is 729 and R is to power 6, 64. So R is to power 6 will be what? 64 divided by 729, right? And if you solve this one, so 64 is what? 2 raised to power 6, and 729 is 3 raised to power 6. We have already calculated the 729. So directly I'm writing this one. So R will be what? R will be 2 upon 3, right? So A is already given. R we have calculated. So easily we can find sum of 7 terms. And this time R is what? Less than 1. So we will use the formula. Yes. Very good. A into 1 minus R raised to power n. So n is 7 divided by 1 minus 2 upon 3. So yes, guys, just write it in simplest form. So this will be what? Into 3 minus 2, 1. So this will be 1 upon 3. So directly I'm writing it in the numerator. So 1 upon 3 will become 3. And this will be what? 2 raised to power, we had already discussed, x upon y raised to power m. So this can be written as x raised to power m divided by y raised to power m. So this can be written as inside the bracket, yes guys, 2 raised to power 7 upon 3 raised to power 7. And directly I'm taking the LCM. So 3 raised to power 7 minus 2 raised to power 7 divided by 3 raised to power 7. Right? So yes, guys, we had already calculated this. 729 is what? 3 raised to power 6. So 3 raised to power 6 into 3, 3 raised to power 7. And in next step, 3 raised to power 7 will be cancelled out. So we are left with 3 raised to power 7 minus 2 raised to power 7. This is S7, right? So finally, if you calculate this one, you will left with what? 2187 minus 128. So finally, your answer will be 2059, right? This is S7. So in this way, you can solve question number 15. Let us move to question number 16. In question number 16, we have to find a GP for which sum of first two terms, only first two terms, right? It means A and AR. And fifth term is 4 times the third term, right? Find a GP for which sum of the first two terms is -4 and the fifth term means A5 is what? 4 times the third term, right? So let us use this information first of all. A5 means what? AR raised to power 5 minus 1, that is 4, and this will be what? 4 times AR square, right? And if we simplify AA gone, R square is equal to 4 and R will be what? R will be plus minus 2, right? So we will make two different cases, right? Case 1 will be what? R is 2, right? So now if R is 2, so now what we can do? Yes. If R is 2, and what we have to find? Uh, find a GP for which sum of two terms. Okay, so sum of n terms was what? Into Sn is equal to A into according to like value of R. Suppose we are taking R is equal to 2. So we will take Sn as, yes, A into. So A is unknown. Yes. R raised to power n. So 2 raised to power, yes, 2 because we are talking about two terms. So A into R raised to power 2 minus 1 divided by 2 minus 1. So in next step, S2 is given -4. So -4 is equal to A into, yes, it will be, yes, 3 upon 1. So A will be what? -4 upon 3. So I think in first case, you are getting -4 upon 3, right? Yes. So if A is -4 by 3 and R is 2, so easily you can find the GP, right? So GP will be A is -4 by 3 into AR. So -4 by 3 into 2, comma, -4 by 3 into 2 square and so on. So this is nothing but it is -4 by 3, -8 by 3, and this is -16 by 3. So this is the required GP, right? When R is 2. So now we will discuss case 2 as well. Case 2 is what? We have R equal to -2. So now S2 will be what? S2 will be A into 1 minus, because R is less than 1. So 1 minus -2 raised to power 2 divided by 1 minus R. right? So here, yes, guys, H2 is already given -4. So A into this one will be what? 2 twos are 4 and 1 minus 4, it is -3 and this is 3, right? 1 plus 2, 3. So 3, 3 gone. A is what? A is -4. Yes, A is -4. Very good. You can check the calculation, guys. If one calculation will be wrong, so whole question will be wrong, right? So if A is -4 and R is -2, so our required GP is what? -4 into, yes, -4 into -2 into -4 into -2 square, right? So this will be what? -4 into -4 comma 8 plus 8 and minus 16, right? In this way, you can find the GP. I hope everybody is clear. Very good. So let us move to question number 17. Here it is given if the 4th, 10th and 16th terms of a GP are X, Y, Z respectively. Prove that X, Y, Z are in GP, right? So to prove X, Y, Z are in GP, we had already solved that question where values are given. Here unknown variables are there. So how we will prove? First of all, we have to prove Y upon X will be equal to Z upon Y, right? So if we prove this one, so it means X, Y, Z are in GP. So fourth term means, yes, A4. So AR cube, right? So AR cube is X and AR, yes, 10th term. So AR 9. So guys, I am directly writing, nth term is what? A into R raised to power n minus 1. So simply A10 means 10 minus 1. So directly I am writing 9. So here this is equal to Y and AR, yes, 15. So that is equal to Z. So first of all, Y upon X, right? So Y upon X will be what? Y upon X will be means, suppose this is 1, this is 2, and this is 3. So 2 upon 1. So this will be AR, AR raised to power 9 divided by AR cube, right? And Z, what is the value of Z? AR 15 divided by Z upon Y. So AR raised to power 9. So AA gone. So here R raised to power 6 and this is 15 minus 9. X, suppose we have X raised to power M and X raised to power N. So then M minus N. So they are the rules of exponents. So here R raised to power 6 and this is also R raised to power 6. It means LHS is equal to RHS. So hence, yes, hence party. So we have like X, Y, Z. So they are in GP. So let us move to next question. Question number 18. Yes. So this question is very important. Look at this question. We have to find the sum of n terms, right? And terms are 8, 88, 888, 4 times 8 and so on, right? So majority of students, so they get confused because here A is 8, but R is not 88 upon 8, like it will be 11. So 888 divided by 88, so that is not 11, right? So what we have to do, what we will do, yes, first of all, if we take sum of n terms, so suppose we are finding Sn and what we are doing, we are taking 8 as common. So first term is 8, so this will be 1. So I am writing in summation format. So 1 plus 88, so 8 is common, so 11. So then 111, then 4 times 1 and so on up to n terms, right? We have n terms. So now again 11 upon 1 is 11, but triple 1 upon 11 is not 11. So again what we have to do now, we will multiply every term with 9, right? This is a special type. You will find many questions related to this one. It can be like 7, 777, 777, and or 555 in this case, like, so method is same. So 8 upon 9. So yes guys, what we have to do, we have to multiply each term with 9. So this will be 4 times 9 plus and so on up to n terms, right? So in next step, what we can do, we can write 9 as 10 minus 1 plus 99 can be written as 100 minus 9 or 10 square minus 1. Similarly, this will be what? 10 cube minus 1 and so on, right? So now I think you guys are very happy now because we have what? If we separate the terms, like terms, so 10, 10 square, 10 cube, and so on up to n times, we have taken n terms, right? Plus 8 upon 9 as it is, and we are left with minus 1, minus 1, minus 1, up to what? These are n terms again, right? So here, this one is GP. So A is 10 and R is also 10, right? So if we talk about sum of these terms, so this will be what? Yes, here we will use 10 into, yes, A into R raised to power n because R is greater than 1. So 10 raised to power n minus 1 divided by 10 minus 1. So this is 10 upon 9 into 10 raised to power n minus 1 divided by nothing because we have taken out 9. So this will be, if we multiply this with, so this will be what? I'm directly writing this one. So 80 upon 81, right? 10 raised to power n minus 1. And this is what? 1 is up to n times. So this will be minus of n. So minus 8 by 9 into n, right? So this is the sum of first n terms, right? You can like note down all the steps how we have solved this question. So finally, yes, 80 upon 81, 10 raised to power n minus 1 minus 8 upon 9n. Yes, very good. This is the final answer. So let us move to next question, question number 19. Find the sum of the products of the corresponding terms of the sequence. This one is very, very important, guys. We had already discussed whenever there is a word problem. So we have to like convert English to mathematics, right? So in many questions, language plays an important role. So corresponding terms means, so what we will do, we have two sequences given. So this is the first term. So we will multiply first term with first term of next sequence. So this way, 2 into 128, like, so sum will be what? 2 into 128 plus 4 into 32 plus 8 into 8, third term. Then fourth term, 16 into, yes, 2 plus 32 into 1 by 6. So guys, if we simplify this one, so this will be what? 256 plus 128 plus 64 plus 32 and 16. So I think now Everybody is happy because this is what? This is GP. A is 256. Here again, you can write it in the form of 2 raised to power, right? So 2 raised to power, this will be 8, then 7, 6 in this way, right? But that is not required. Directly, you can save your time. A will be 256 and R will be what? 128 divided by 256. So this will be 1 by 2. So A and R are known. So what we can do? We can find the sum. And here we are having 1, 2, 3, 4, 5. So 5 terms are there. So mainly we are finding S5 means N equal to 5, right? So S5 will be what? A into 256 into, yes, R is 1 upon 2. So we will use 1 minus R raised to power N. So N is 5 divided by 1 minus 1 by 2, right? So here guys, yes, 256, 1 minus 1 by 2. So it is 2. So 256 into 2 and this will be what? This will be same type we have solved 1 minus. So this will be 1 upon 2 raised to power 5. And if we take the LCM, so 2 raised to power 5 minus 1. And this will be what? 2 raised to power 5. Right? So this will be what? Uh, 2 raised to power 256 is equal to 2 raised to power 8. So 2 raised to power 8 into 2 raised to 2. So this will be what? Combine. This will be 2 raised to power 9. So 2 raised to power 9 and divided by 2 raised to power 5. So this will be 2 raised to power 4 and this will be as it is. Right? So this will be how much? 16 and 32 minus 1, 31. So now finally you can write the answer 16 into 31. So this will be 496. Very good. So finally we got the answer, right? I think everybody is clear about these steps. Guys, we are solving question number 19, right? So now I'm not writing the formula every time, and I'm sure once you will solve this exercise, so till the time like you will solve fifth or sixth question. But I will recommend write formula in every question, right? So let us move to next question. Next question is what? Show that the products of the corresponding terms of the sequences this and this form a GP and find the common ratio. Just like previous one, but this time they had given what? They had given the terms, right? So terms are unknown, right? So now product of this one form a GP and find the common ratio. So let us solve the question. So product, yes. So product will be what? A into first term is A. So here first term is A, capital A. So here first term is AR. So here first term is, I'm writing inside the bracket. So then AR square and here it is AR square. So then, yes guys, this is up to, okay, last term is what? AR n minus 1. So they are mainly talking about n terms, right? So this will be what? AR n minus 1, right? So if this is the first term, so let us check whether second term divided by first term. So that is AR A into A. So that is equal to third term divided by second term. So if we check this one, so yes, let us simplify. A gone, capital A is gone. So this will be what? R into R. And this will be A gone. This one gone. A gone. One R is left and one small r is left. Yes, both are equal to Same. So it means, yes, find the common ratio. So this is the common ratio. Yes, guys, this is the common ratio, right? So in this way, we can easily solve question number 20, right? So this is forming a GP, and first term is small a into capital A, and the common ratio is this one, R, right? So this is the final result. So let us move to question number 21, right? So question number 21 is find four numbers forming a GP in which third term is greater than the first term by 9, right? So third term, let us translate English to maths. Third term is greater than first term is by 9, and second term is greater than the fourth term is equal to 18, right? So if we talk about third term, so third term is what in a standard GP? Yes, AR square, and first term is A, so this is equal to 9, and second term is AR, and fourth term is AR cube, so this is equal to 18. So now if we take out A common, so we are left with R square minus 1. So this will be your first equation, right? Similarly from here, if we take AR common, right? So 1 minus R square is equal to 18, right? So what we can do, we can take minus 1 as common, right? So minus AR will be equal to minus R square is equal to R square minus 1 is equal to 18. Why I'm taking minus 1 is common? Because in equation number 1, we have R square minus 1, right? So same process, what we will do, 2 upon 1. So 2 upon 1 will give us what? A gone, and we are left with what? Minus R, and minus R is equal to 18 upon 9. So that is 2. So value of R is minus 2, right? So if R is minus 2, so I think now you can simply, by substituting R equal to minus 2 here, so it will be 4 minus 1. So 4 minus 1 is 3, and A will be what? 9 upon 3. So A will be 3, right? So in question number 21, yes, R is minus 2 and A is 3. Very good. So now easily you can find the four terms. So what is the first term? Yes, first term is A, then second term AR. So 3 into minus 2. Third term 3 into minus 2 square, and fourth term is 3 into minus 2 cube, right? If you want to simplify this one, so then it will be what? 3 into minus 6 and plus 12, right? Negative raised to power even, and negative raised to power odd. So this is negative, and this will be minus 24. So guys, these are the final required four numbers, right? So in this way, you can solve question number 21. So now let us solve question number 22. So if pth, qth and rth terms of a GP are A, B and C respectively, so then we have to prove A raised to power q minus r into B raised to power r minus p into C raised to power p minus q is equal to 1, right? So here A, B and C are already involved, even R is involved. So what we can do, we can write the general term of GP as AR, AR square, AR cube and so on, right? So here we know nth term. So nth term of this GP will be given as a into r raised to power n minus 1. So according to question, pth term. So pth term will be what? A into r raised to power p minus 1, right? Similarly, qth term will be, and this is given as a, right? So a raised to power a into r raised to power q minus 1, this is equal to b. So finally, rth term is a into r raised to power r minus 1. So that is given as c. So now what we will do, here we need a raised to power q minus r. So what we will do, we will take q minus rth power of this first one, right? So if we take the q minus r power of this one, so what we will get? Yes, so here a to power q minus r will be there, right? And for r, it will be what? P minus 1 into q minus r, right? Similarly, for b raised to power r minus p. So what we will do? Yes, for here we are taking power r minus p. So taking power r minus p on both sides. So here we will get a raised to power r minus p and r raised to power, yes, q minus 1 is already there, and we will multiply this with r minus p, right? Similarly, last is what? C into p minus q. So that will be a raised to power p minus q and r raised to power, yes, it is what? R minus 1 is already there, and we are multiplying with p minus q, right? So now what we will do, suppose these are 1, 2 and 3. If we multiply 1 into 2 into 3, so on left hand side we will get what? This one. So it means this is the left hand side of required this proof, right? So on the right hand side, so you can see a raised to power q minus r, a raised to power r minus p, a raised to power this one. So we will add the powers because base is same. So it will be q minus r plus r minus p plus p minus q, right? So here we don't have extra space, so I'm writing the r raised to power on the downside. So r raised to power p minus 2 into q minus r. So directly I'm multiplying. So this will be pq minus pr minus q plus r, right? Similarly, this one r raised to power. So this will be what? Plus qr and minus pq, then minus r and plus p, right? So then this product is left. So I'm continuing this here. So this will be what? R into P means PR. Sorry, this is PR. So PR minus QR minus P plus Q, right? So at last, what we will do, we will cancel the terms which are like common. So Q and Q, this is minus Q and plus Q gone, minus R plus R is gone, and minus P plus P is gone. So we are left with what? A raised to power 0. Similarly, if we talk about R, So we are having PQ positive here, and this is minus PQ. So minus PR plus PR minus Q plus Q plus R minus R. So QR minus R and plus P minus P. So we are having R raised to power 0. So A raised to power 0 and R raised to power 0. This will be what? This will be 1, and which is the required right hand side. Right? So LHS is equal to RHS. So hence party. So I think everybody is clear about this one. So this is simply like we have to, first of all, we are writing the journal term of GP. So then what is given? So we have written that one. So according to question, so now we need A raised to power Q minus R, and we are having only A. So we are taking power of Q minus R on both sides. So we have just written this one. Similarly, this one and this one. So finally, we have multiplied these left hand sides and we got required right hand side. So, okay, so now let us move to question number 23. If the first and the nth term of a GP are A and B, right? And if P is the product of n terms, so prove that P square is equal to AB raised to power n, right? So this is first term and nth term of GP are A and B. So we know in a journal standard GP, so this is a GP, so first term is A, so it is already given. And nth term is what? AR raised to power n minus 1. So here, this is your first term and nth term is this one, right? And this is given as B, right? So B is given as this, yes, right. So if P is the product of n terms, so P is the product of n terms. So product of n terms means AR square, and this will be multiplied till AR raised to power n minus 1. So yes, guys, if we multiply P n times, so this will be A raised to power n. And if we talk about R, so R raised to power 0 is here. So power of R. So they will be added. And finally, we have n minus 1. Right? So A raised to power n is okay, but R raised to power 1 plus 2 plus 3. So I think everybody is aware about this one. If we have first n terms, so that is the rule is what? N into n plus 1 upon 2. But here we are having up to, yes, we are having sum of first n minus 1 terms, right? R raised to power. So what we can do, we will write it as, yes, so we are replacing n with n minus 1. So n minus 1 plus 1 divided by 2. So this is nothing but this is n into n minus 1 upon 2, right? So this can be written as A raised to power n into R raised to power n into n minus 1 upon 2, right? So this is P. So now we need P square. So let us write P square. So P square will be what? Squaring on both sides. So in this case, this will become 2 raised to power n, and R will be 2 into, so 2 will be cancelled out, and we are left with n into n minus 1, right? So you can see n is common. So here what we can do, we can write it as A square into R raised to power n minus 1 and whole raised to power n, right? In next step, what we can do, A square can be written as A into A, and R raised to power n minus 1 is as it is. And you can see what is given. Yes, So this A into R raised to power n minus 1, that is given as B. So AB raised to power n, and that is what? P square, right? So this we have to prove P square is equal to AB raised to power n. So we have proved this one. So hence party, right? So let us move to another question. Question number 24. Show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1th to 2nth term is 1 upon r raised to power n, right? So what we will do, show that the ratio of the sum of first n terms. So we have ar square and so on, right? So sum of n terms. What is the sum of n terms? Yes. So that is equal to, yes, it is equal to a into 1 minus r raised to power n divided by 1 minus r, right? So then next n plus 1th term to 2n 2nth term means they are again talking about next n terms. So I'm writing capital N here. So here first term is what? N plus 1th term means that is what? A into a n plus 1, right? So this is the first term for next n terms. And here ratio is same, 1 minus r, right? So now we know nth term is what? In this standard GP, nth term is what? It is AR n minus 1. And here we are having AN plus 1. So if we need AN plus 1, so that is nothing but it is replacing n with n plus 1. So if we replace n with n plus 1, so after solving, we will get AR raised to power n only, right? So here we are having what? AR raised to power n 1 minus r raised to power n divided by 1 minus r, right? And we are looking for ratio of sum of this and this, right? So means we have to find what? Sn upon this S capital N. So yes, Sn is what? It is A into 1 minus r raised to power n 1 minus r. So this is equal to 1 minus r divided by a r raised to power n 1 minus r raised to power n, right? So after simplification, a is gone, 1 minus r raised to power n is gone, 1 minus r is gone, and we are left with what? 1 upon r raised to power n, and which is the required term. So that is ratio is 1 upon r raised to power n. So hence party, right? So let us move to another question. So these questions are like many students, they find these questions very complicated, but questions are very easy. Just remember the steps, right? Whatever is given. So initially we have to translate English to maths. So then according to our requirement, we will follow next steps. So let us move to another question. So here we are having if A, B, C, and D are in GP, show that a square plus b square plus c square into b square plus c square plus d square is equal to ab plus bc plus cd whole square, right? So what is the standard form of GP? It is ar, ar square, ar cube, and so on, right? So if they are in GP, so let us assume a is a, so b is what? B is ar, c is ar square, and d is ar cube, right? So directly I'm writing a square. So a square will be simply a square, right? Plus b square. B is what? AR. So b square will be a square r square. C is what? C is AR square. So this will be what? A square r raised to power 4. And what about b square? B is AR. So this will be A square R square. C is what? C is AR square. So this will be A square R raised to power 4. And what about D? D is AR cube. So this is A square R raised to power 6. Right? So then if you talk about right hand side AB, AB is what? AB is A square R plus BC. Yes. So this is A square R cube. I'm just multiplying B and C, AR into AR square. So then CD is what? AR square into AR cube. So that will be equal to, yes, A square CD R raised to power 2 plus 3, 5, right? And this is whole square. So now let us take common from this one. We are having A square common. So 1 plus R square plus R raised to power 4. And from here, I think we can take out A square common and R square common. Yes. So 1 plus R square plus R raised to power 4. And from here, A square R is common and again square of that one. So this will be what? A A square R whole square, right? And what is left? 1 plus R plus R raised to power, no, 1 plus R square, because we are taking 1 R outside. So this will be 4 and whole square. So now combine this one, A square, so A raised to power 4, R square, and this will be what? 1 plus R square plus R raised to power 4 square, this into this. And here on right hand side, A raised to power 4 R square, and this is what? 1 plus R square plus R raised to power 4 square. So if we see left hand side, so that is equal to RHS. So hence party, right? So in this way, we can easily prove LHS is equal to RHS. So let us move to another question. So here we have to insert two numbers between 3 and 81 so that the resulting sequence is GP, right? So let us assume two numbers are N1 and N2 between 3 and 81, right? So you know the standard form of GP. So this will be A, this will be AR, this will be AR square, and this will be AR cube, right? So A is 3. What about AR cube? This is 81 and A is already there. So 3R cube is equal to 81. So in next step, what we can do, we can simplify this one, and 27 can be written as 3 raised to power 3. So the value of R will be 3, right? So A is 3 and R is also 3. So easily we can find N1. So first number is what? First number is A into R. So that will be 9. And what about second? A into R square. So that will be what? 3 3s are 9, 3s are 27. So two numbers 9 and 27. If we insert these 9 and 27 between 3 and 81, so resulting numbers, so that will be what? 3, 9, 27 and 81. So they will be in GP, right? So I hope everybody is clear. So let us move to another question. So here we have to find the value of n so that this a raised to power n plus 1 plus b raised to power n plus 1 divided by a raised to power n plus b raised to power n may be in geometric mean between a and b, right? So I'm writing the formula. So whenever we have, suppose we have n terms, right? So how to find its GM? So GM will be calculated as nth root of product of n terms, right? Suppose there are n terms, so we will write the product, right? So here we are having only two terms, right? So n will be replaced with 2. So there is no need to write 2 because it is a square root. So GM of A and B, so that will be what? That will be simply under root AB, right? So find the value of n so that this may be the geometric mean. So according to question, it is already given that a n plus 1 plus b raised to power n plus 1 divided by a raised to power n plus b raised to power n. So that is equal to under root AB, right? So now what we will do, we will square both sides, right? So squaring both sides, yes guys, what we will get? So here left hand side, so you know a plus b whole square. So it is a square plus 2ab plus b square. So here what we will get? Yes, a raised to power. Yes. So here don't get confused. It is what? This one. So in next step, we will write it as 2n plus 2. Right? So directly I'm writing this one. So a raised to power 2n plus 2 plus 2 into a n plus 1 and b raised to power n plus 1 2ab plus b square. So b square will be 2n plus 2 and this one is divided by, yes, a raised to power 2n plus 2a raised to power n b raised to power n plus b raised to power 2n, and this will be what? If we do the square root of, if we do the square of under root AB, so this will be simply AB, right? So now in next step, what we will do? We will do cross multiplication. So I'm just writing the right hand side because left hand side will be as it is, right? Till this point. So here what we will get? This will be AB is multiplied with this one. So yes, it will be 2n a 2n into a raised to power 1. So this will be 2n plus 1 into b plus 2 into a. So a raised to power n and a. So this will be n plus 1. Similarly, b will be n plus 1. And for last, b raised to power 2n. So I'm writing a as it is because there is a into b raised to power 2n. So 1. So this will be 2n plus 1, right? So if we check, this is the left hand side, this one, and this will be the right hand side. So I think this one and this one, so they are same. So we are left with what? A raised to power 2n plus 2 plus b raised to power 2n plus 2 and is equal to a raised to power 2n plus 1 into b plus a raised to power b 2n plus 1. So I'm saving one step. So what we can do? We can take out a raised to power 2n plus 1b on the left hand side. So this will be 2n plus 1 into b, and on right hand side we are left with ab raised to power 2n plus 1, and this will be gone to right hand side. So b raised to power 2n plus 2, right? So now a raised to power 2n plus 2 and this is 2n plus 1. So we can take out a raised to power 2n plus 1 is common. So here we are left with what? Only a, because it is what? A raised to power 2n plus 1 plus 1. And here 2n plus 1, a raised to power 2n plus 1 is out. So we are left with b only. Similarly, on right hand side, what we will take out? B raised to power 2n plus 1. So we will left with a minus b. So a minus b gone. So here we are left with a upon b whole raised to power 2n plus 1. And this is equal to 1. And to make base as same, what we can do? We can write 1 as a upon b raised to power 0. Now base is same, so we can compare the terms. We can compare the powers. So 2n plus 1 is 0. So n will be what? N will be minus 1 upon 2. Right? So what is the final value of n? It is minus 1 upon 2. I think everybody is clear about the step. You can watch recording 2-3 times. This is very easy question. Right? So now let us move to next question. So finally, let me check the answer. N is equal to minus 1 by 2. Yes, very good. So now question number 28. The sum of two numbers is 6 times their geometric mean. Show that numbers are in the ratio this one. Yes, so let us assume two numbers are A and B. So what is given? It is given that A plus B sum is 6 times their geometric mean, and we have already calculated geometric mean of A and B is root AB, right? So now show that they are in the ratio this one, right? So it means we also need what? A minus B to find A and B, right? So this is first equation. So now what we will do, this relation is very important. We had already discussed this in quadratic equation, a minus b whole square. So that is equal to what? A plus b whole square minus 4 times a into b, right? So a plus b whole square is what? It is 6 under root ab. So this square minus 4ab. So this is what? 36ab and 4ab. So this will be 32ab, right? So what will be a minus b? A minus b will be taking under root of this one. So this will be 4 root 2 into under root ab. So this will be your second equation. So what we will do? Now it is very easy. A plus b is given, a minus b we have calculated. So we will add 1 and 2. So 1 and 2 gives us 2a. 2 times a will be equal to what? Yes. So this will be what? 6 plus 4 root 2. Right? And root ab is common. And in next step, we can take out 2 common from here. And we are left with what? A value. So 2 cancel out. So a value will be what? 3 plus 2 root 2. Right? Similarly, find just we have found a equal to this one. So now we will substitute a equal to 3 plus 2 root 2 in equation number 1 or 2. Right? So suppose we substitute this in equation number 1. So we are left with what? 3 plus 2 root 2, right? So a is what? No. One thing is missing. This is 3 plus 2 root 2. Root ab is there, right? So 3 plus 2 root 2 into ab Yes, we have substituted value of a here, and this is equal to 6 times root ab. So yes, guys, what will be the value of b then? Yes, after solving this one, uh, this is 3 root ab. So this is 3 root ab and 6 root ab. So b will be what? 3 root ab and 6 root ab. So this will be 3 into root ab, right? And this is as it is, minus 2 root 2 under root ab, right? In next step, what you can do, you can take under root ab common, right? And now look at the value of a and b. If you take the ratio of a is to b, means a upon b. So root ab will be cancelled out and you will get your desired answer, right? So hence party. So let us move to next question. Question number 29. If A and GB, AM and GM respectively between two positive numbers, so prove that numbers are A plus minus, A plus G, A minus G, right? So here again same process. Suppose two numbers are A and B. So AM. So AM is what? G. So A is equal to A plus B upon 2. AM is A. So means that is it is arithmetic mean. Yes. So arithmetic mean is what? Between two numbers A plus B divided by 2. And if we talk about GM, so that we have already calculated, right? So now what we will do from here, I think we can write it as A plus B equal to 2 times A. So that is your first equation, right? So now same process, we need A minus B. So we will use that previous formula. So it will be A plus B whole square minus 4 times AB. So yes, guys, this will be what? 4A square. I'm directly substituting A plus B equal to 2A. So that will be 4A square minus, yes, 4 times AB. AB is the what? Squaring both sides. So G square. So this will be G square. And if we take out 4 common, so this will be A square minus G square, and this will be A minus G into A plus G, right? So in next step, what we can do, we can take under root on both sides. So this will be what? 2 into A minus G, and this will be A plus G, right? So I think now we have our equation 2. So same process, 1 plus 2. So 1 plus 2 will give you 2 times A. 2 times A is equal to what? Yes, 2 times A will be equal to, on right hand side, it is 2A plus this one. So 2 times, yes, A plus, as it is, A plus G and A minus G, right? So 2 gone, the value of A is this one. Similarly, by substituting A is equal to this in equation number 1. So what we will get? A plus under root A plus G, A minus G. So that is equal to what? Plus B, sorry. Plus B. So that is equal to A. And now B will be what? 2A minus A. So that is A minus, as it is a plus g into a minus g. So now guys, it is clear. A is what? The value of a was a plus under root a plus g into a minus g, right? And this is a plus g into a minus g. And this is the, like, we have to prove two numbers are a plus under root a plus g, a minus g. So that is the value of a. And second is what? A minus. So in one time you will take a plus this one, and in second time you will take a minus this one. So two numbers we had assumed, a and b, and first number is a plus this term, and second is a minus this one. So hence party. So in this way, we can solve question number 29. Let us move to question number 30. So here it is given the number of bacteria in a certain culture doubles every hour, right? It is doubling after every hour if there are 30 bacteria present in the original culture. So, right, so it is very easy question. In initially it is 30. So means next time it is doubling. So 30 will become 30 into 2. In next time, it will be 30 into 2 into again 2, right? So this will become a GP, right? So now here, if you talk about A, so that is 30 and R will be 2, right? So they are asking for what? How many bacteria will be present at the end of second hour? So at the end of second hour means they are asking for what? A3, right? So that is what? AR raised to power n minus 2. And A is already there, 30. R is 2. N is what? 3 minus, sorry, n minus 1. Nth term is An is equal to A R raised to power n minus 1. So this will be what? 3 minus 1 is 2. So it will be 120. Similarly, you can find after fourth hour means they are asking for A5. So A5 will be A R raised to power 5 minus 1, right? So that will be 4. So this will be 30 into 2 raised to power 4. So that is 480, right? So similarly, after nth hour, so what we will do? We will replace this with n. So 30 into 2 raised to power n. So that is the after nth, and this is after fifth hour, and this was after second hour. So in this way we can easily find the answer. So let us move to another question, question number 31. So what will rupees 500 amounts to in 10 years after its deposit in a bank which pays annual interest rate of 10% compounded annually, right? So this question, if you know the formula related to what? Compound interest. So that is what? A is equal to P into 1 plus R raised to power 100 raised to power N, right? N is what? Number of years, that is 10, R is 10, and P is 500. So in fraction of seconds, we can solve the question. But here in this question, because it is in like GP, so what we will do, we will form a GP for this one. So look at this one. Initially, there are 500 rupees in the account, right? So after 1 year, there will be interest of 10%, right? So you know how to calculate interest. So it will be what? 500 plus 10% interest on 500. So if you take out 500 common, so you are left with what? This is 0.1. And this is what? 500 1.1. So 500 into 1.1. Right? Similarly, when you find the interest on this one, because principal is changing, always remember, in case of compound interest, principal also changes after that particular time interval. So for next year, this will be the principal, right? 500 into this one. And if you calculate this similarly, this to 1.1, so in next one it will be 500 into 1.1 square, and so on. So this will form a GP, and A is what? A will be 500 and R will be your 1.1, right? So they are asking for what? What will be this in 10 years after its deposit in a bank, right? So look at this one after 1 year. It is this one after 2 years. This is the amount. So after 10 years, yes, this will be what? 500 into 1.1 raised to power 10. So in this way, we can easily find the answer, right? So question number 31. Yes, 500 into 1.1 raised to power 10. So this will be the answer. So let us move to next question. Here, AM and GM of roots of a quadratic equation are 8 and 5 respectively. So then obtain the quadratic equation, right? So let us assume A and B are the roots of quadratic equation. So if A and B are the roots of quadratic equation, so always remember that quadratic equation will be what? X square minus sum of roots and plus product of roots is equal to 0. We can easily frame the quadratic equation. So, and I think now everybody is happy. Why? Because AM is what? Arithmetic mean is always A plus B divided by 2, right? And it is already given, it is 8. So A plus B divided by 2 is 8. So A plus B will be 16, right? Similarly, GM is given as 5. So under root AB is given as 5. So AB will be 25. So easily in fraction of seconds, you can find the answer. So x square minus, yes, AB is 16. So 16x plus 25 is equal to 0. So in this way, you can find the required quadratic equation. So I hope everybody is getting all the solutions, right? So thank you guys. This is all about your chapter number sequence and series, right? It is chapter 8 and we have also covered exercise 8.2, right? If you like this lecture, so then please share this with your friends. And if you have any type of doubt, you can write your doubts in the comment section. And for more interesting educational videos, you can subscribe Arena World Education. And thank you once again. Bye bye. Take care.